Hello everybody. Okay, so today we're going to be doing buffer overflow 6 on TryHackMe. This is a little bit of a follow-on from my first video. The first video was a bit of a slower one, but today we're going to do it a little bit faster for those of you who just want a bit of a reminder or whatever. So what I've done is I made a little bit of a cheat sheet for myself containing the scripts that are on TryHackMe. I'll put these in the description, so all you've got to do is copy and paste these things into your box and then you can have it forever. So these are ones I stole from TryHackMe. They were on the little walkthrough things that are available on there. And this little thing up here is sort of my step-by-step sort of checklist to go through when we're doing buffer overflows. So yeah, so without further ado, let's get stuck in. So this is our buffer overflow machine right here. Go to the top, go to desktop. So I'm doing this one live today, so if anything goes wrong, you'll see me mess it up. So Windows, what am I doing here? Users, admin, desktop, vulnerable apps, OSCP, and there we go, run it. Okay, we're looking good. So let's test the NLVP, machine 10.10.101. Test the thing is running. Oh, and we need to put that in as well. Okay, here we go for help. And then we get that. Okay, we're going to do Overflow6 today. Like, I haven't done this one yet, so I don't know. I literally don't know what values it's going to have. So overflow is complete. It's running successfully. So let's go. Clear, and again clear. Okay, so no fuzzer. Okay, so we need to change the input. Where is it? A's is correct. Count is correct. Overflow 1. We need to change this to overflow 6 because that is the one we're doing. It basically just tells this script to change to whatever program, whatever input we can be using. Okay, so I also need to change the IP because it was set to something different. IP is, what is it? 101. 101 and then 34. Okay. And then that. And we're just going to Python fuzzer, wait for that to do stuff. Python fuzzer, see where it crashes. Okay, cool, it seems to be working because you saw values changing here, so that's good. Okay, so first thing run as the immunity debugger. Set local working folder in Mona, I haven't done that. So let's copy this command into here. Okay, I wonder if it'll work today. Yes, it works today, perfect. So this sets our local folder or working directory within the immunity debugger to this location. So that's good. Okay, then we've just fuzzed it and we've crashed to 1100 bytes. That's good. So now we need to create a pattern. So we get said pattern just by here. Copy selection, paste here. And then what do we crash at 1100? So we take the 1100 and we'll add 400 bytes to it just to make sure we do overflow the buffer. So that'll be 1500. We need to restart this again because obviously it's crashed. Okay, run it again. Just double tap on next, sometimes it can be a bit funny. Create the pattern, wait for this to do its thing. Okay, now we need to copy this, and then we go nano exploit, and then in the payload, we need to put the payload in there, which is our pattern, see where the EIP overflows. Okay, then we need to change the IP because this is a new script. So 101, and then we go, what was it? 34. So overflow, change the prefix to overflow 6. No offset as of yet, so that's fine. A times 0 is 0. That looks good to me, so we'll see what happens. Okay, so we go to Python exploit now. Let's just check the step-by-step guide or cheat sheet. So we found the what's the name. Now we need to run this, and then we need to do find it at whatever distance, or we can do that. So we'll do this one today because this one's better than that one, I find. Okay, so let's run the exploit. Okay, crashed that, perfect. So now what we're going to do, there are two ways to do this. I'm going to do it the MSF way. The tutorials do it a different way on the TryHackMe stuff. So if you're interested in doing it their way, I suggest you look at that. I've got both in here just in case one way doesn't work over the other, but I just prefer this way because I think it's more reliable and it's easier for me. So MSF pattern offset, this is wrong as well, this needs updating, L-Q, so this is going to be the same as that. Why isn't that updated? Let me just quickly update that. Okay, I'll quickly just save that. Yeah, so ALSR Q, it might be a capital Q, so if this doesn't work then we'll do that. So what we're going to do is the EIP, that is the bytes that this is the value we put in there through our pattern. So we're somewhere in here is this value. So all we can do is we can just create another pattern, but look for these bytes in here, and it'll tell you what the offset is. So paste clipboard, and we go boom. Offset match 1034. Now I'm quite happy with that, but just to prove to you that this does work, what I'm going to do to you, is just do that in there, copy that command in there. Remember, look for the distance. I think I put 1500, so we'll just do that, and then you'll see down here the EIP is located at 1034, which is what we had here. So this is just a little bit of a faster way than messing around with immunity. So as this is crashed, we start this up again, run this up, get experience. We've got a fresh version in there. Now we need to create a we know the offset, so we need to change the exploit to be offset of 1034 because we now know what that is, 1034. Overflow is cool, and then the CCC value, let's put C in there, CCC. Okay, so overflow is going to be lots of A's, we're going to have a C in there, then we're going to control K this, control K, and then pay load equals nothing, and that, okay, X, that sounds good. Okay, now we need to create a byte array to compare to. Because we need to prove that we control the ERP, but we can do this when we do our bad chars as well. So Mona byte array, so this is create the byte array to compare potential bad bytes to. Okay, so this is our byte array. Cool. So let's go back. We might as well create a bad character list as well whilst we're at it, because we can send a bad characters and check our EIP at the same time. So let's have a character and create. Find a distance, we've done that. Create a byte array, yeah, we've just done that. Generate a bad chars for the payload using the script. Okay, so we have a bad chars script, which I don't think I've made actually. I forgot to do that. Exploit fuzzer. Yeah, I didn't do it. Okay. Or did I? What's that there? Bad chars. Cat. Bad chars. Oh, I did do it. I didn't save it as Python script. So move bar chars to bar chars dot py. Okay. So let's just now know that bad chars dot py. I think we need to change a couple of things. No, it looks quite good actually. So we already know there's bad chars of xx0, so you can get that in there. Yeah, okay, go. Yep, so let's run that, create our bad chars list, bad chars, that runs that without our xx0 because we've already taken out of our list anyway. Copy selection, and we go to nano exploit py. Okay. And then padding, we don't do padding just yet. Payload is going to be our bad characters list, which we've just done. Paste. Okay, let's have a little look over this code, make sure it's right. So the offset is lots of A's, 1034. And then we reach our EIP register, and we're going to put in the value of CCCC, so we have 43 in there. And then we're going to generate past the payload, and then from here we can start checking for bad characters all in one. So let's go. Cool. So Python exploit. Oh, I'm so lazy. I might just type it, it'd be faster. Python. Okay, that's crashed it. Crashed. We've got control of the EIP. Okay, that's good. Lots of overflows there. Okay, we're looking good. Okay, so now let's go for generate bar chars from the payload. Yep. Compare bar chars. So now what we need to do is we need to copy this, put that in there. I gotta copy it and I can't do that. Copy in here, and we go paste, and then we go, so the ESP, location of the ESP, wherever that might be. So the ESP says pointed there. So we'll copy the ESP, copy to clipboard, paste that in there, and then that should take us to show us our bad characters. So that's good. So like we've done before, we do every second character. So we know this is bad character, and then this is our first bad character. So in our little list, we're going to go nano bad chars py, and then we're going to go backslash 08. Then we go backslash 8. So we do it every second character after the first bad character. So this is our first bad character. Skip this one, 2C. So the reason why we do this is because for some reason, when the first bad character is hit, the program also assumes that the second character is also a bad character. Then it proceeds with the code execution till it hits the next bad character, and that's why we get so bad character, zoom, bad character, zoom, bad character. So we've got bad character, bad character, bad character. Okay, and then we're basically be checking for these bad characters until no more bad characters appear. Then we can insert our payload and get a reverse shell. Okay, so what are we on? 2C. Now we go to AD. So X AD. Cool. So let's double check that. 0 0 8 8. Yep. 2C. XAD. XAD. That looks good to me. So we need to generate a new bad character list. So we go Python bad chars.py, run that. That looks good. Then we're going to go copy this into our exploit. Exploit db nano exploit py. Oh no. Okay. And what we're going to do, coming down to here, we're going to control the K, the payload again, and then we put on a new payload of bad characters equals to. Oh, come on. This. Then. Oh no. We go paste clipboard. That looks good to me. Let's make sure there's no 8s in there. Yeah, it worked. Okay, I'm happy with that. Okay, so our payload is now ready. So now what we need to do is we need to restart our program. Restart OSCP. Okay, go in. Press play twice just to make sure it takes. And then we're going to crash it again. Oh, not nano. Nano ain't going to do it, is it? Python exploit.py. Okay, it's crashed again. That looks good to me. Now we're going to change this to new ESP locate. Oh no, sorry. We got to update our byte array to include our new bad characters. So let's just cycle through our commands. Here we go. Here's our Mona byte array. So we're going to update this array as well to our new bad characters. Our bad characters were, if I can remember, which I can't, nano exploit, nano bad chars. There you go. So basically just this again. So this time we're not going to do the escape. So if you're not proficient in Python, this is an escape character, but to escape the escape character you put another character. So that's how that works. If you don't know what escape characters are, I'm not going to tell you. You should go away and learn. It's we'll find plenty of stuff online for that. So 6AD. So 0 0 0 0 0 8 0 8 2C XAD. Okay, I'm happy with that. So let's generate our new byte array to compare to. Now it looks good to me. We've already crashed this, so now we're going to go back up to our that's it. Find our stuff. We're going to get rid of this location. Then we're going to copy the ESP. We're going to copy selection board. Okay, bang that in there, and then we're going to hopefully no bad characters. Looking good. So now we know what our bad characters are, we can now insert our payload into our exploit. So in order to do that, what we've got to do is, oh yeah, we've got it for a jump point as well. So now we're in this situation. Now we know that we don't have any bad characters. We need to look for a jump point using our bad characters. So copy this. I suggest go and finding those bad characters again we used for our byte array. Yep, go in there, get rid of that. Copy our code we got. Oh, I think our Mona commands even. Oh, no, not that. Helps if I actually copied it, doesn't it? Copy selection. Over here. Then we go paste. Okay, looking for a jump point. Okay, click that in there, and then we should get a jump point. If this happens, don't worry, just go into window, just log data. And then here we see a jump ESP point. So what we're looking for in here, so we're looking for a point such as these that are located, that don't have ALSR false, we erase false, so basically no code flow protections. So we're going to take this value and we're going to put it into our RETN point and our exploit. So exploit py and go to RETN here. This is going to be the EIP, so this is where the EIP is going to move to next on our code. Because these systems are generally a little endian, put this in backwards. I know it sounds weird, but that's just the way it is. So put that in using the x values as we did before, xaf, and then it was \x 111 \x 50 \x 62. Okay, that's a byte. 1, 2, 3, 4. Cool. Let's save that. We need to update our payload in a minute. So it's just, yeah, that's correct. That's correct. This is all looking happy. Good. So now let's do our payload. So in here we have update your item value ERP like this. This will be found. That's cool. This is what I mean by putting this. So this is what I mean when we put this thing in here. We put it in backwards because remember it's likely to be a little endian. Okay. Yep. Maybe say look for a jump point that has the ALSR value as false. So now we generate our payload. So we're gonna. Oh, that's a bit wider than I thought it was going to be. So we're going to generate our payload. We're going to go boom like that. Take that, and I'm going to put it in here. Paste select clipboard. Our payload is looking good. It didn't work because obviously I had the wrong values in, so it needs to change. So what was that one? It was 08, and then that was 2C. Oh god. Oh yeah. There's a fat finger in it. AED. Here we go. And then our port. 4444. And then local host IP. I don't know what my IP is. Let's just find out quickly. IF config. I think it's IP address show actually. IPA show. And then this one here. It's my location. Okay, where am I? Here. Okay, cool. That should work now. As long as I get through the first bit. So let's just run this over. Double check it. Looks good. MSFNM. Payload. Windows shell. Reverse shell. Localhost. My port. Bad characters. Exit function thread. Python. Payload. Cool. So run that now. That'll give me a payload. And then we go nano exploit. So again, we go down to payload. Control K. Payload. I don't need to plan that actually because it already comes with one. Wait for MSF to do its thing. Yep, we're happy now. So payload. Yep, come on, let's go. Okay, we need all of this. Oh damn it, I didn't put a thing on the end. Copy selection. And then we go paste. And then we put a little thing on the end. Oh, please pain in the bum. Come on. Highlight. Oh no, everything's going wrong. Here we go. Let me get rid of that one. Okay, and then put an offset in. Where is it? Put padding. Put something of padding in there. What we usually used before. I think it was 0x90. I think it was some sort of NOP sled. 0x90. Oh, 090. And then put a byte. Put a 16 bytes in there. Just this is basically adds a little bit of padding, so any kind of over if there's any extra code or something we haven't accounted for, it will eat into this padding. It won't it won't affect our program. So it will basically eat into this, and then after this it will flow into here. Cool. So I think that looks good. Payload, that looks all good. Okay, we'll just do it. Exit. Okay, let's restart this. OSCP. Run. And run again. And then we'll set up our netcat listener. There we can. And RVP 4444. Okay, that's good. Okay, let's send our exploit. Python on exploit. Run. And it didn't work. I've done something wrong here. I do apologise all. My payload was a little bit off. It's missing a number. So let's go back. Let's get rid of this payload. And I've just done it all wrong, haven't I? So Control K. Just gonna smash through this. Get rid of this payload. Cool. And then on here, that was all good. This is all good. So this doesn't really need to be too concerned with. So let's update our payload. Go back to here. Okay. Wait a few seconds for this to do its thing. That goes over here. That goes over here. We're going to move this just by over here. Cool. And then, why is that a 0 at the end? Okay, well, I'm not going to argue. Copy selection. Right there. Yeah. Payload. Okay. Right, let's try this one. Exit. Next that, listening. Python exploit. Root done. Nothing. Did this even flow? Let's run it again. Okay, flow. There we go. Boom. Here am I. Some guy called OSCP bot. Cool. So there you go. There you have it. Buffer overflow in less than 23 minutes. I hope you enjoyed it. I mean, yes, it was a very quick lesson. I just wanted to rattle through it because I did a long video explaining this whole process a little bit better today. But I just wanted to go through the little script I'm going to attach with this video, step by step, just explaining it very quickly. So this sort of stuff, getting this down will be good preparation for the OSCP. And just be your general basic buffer overflows going forward. Okay, well, videos. Well, yeah, I hope you enjoyed it. If you have any questions regarding this sort of stuff, please put it in the comments, and I'll try and get back to you with anything any answers. If there's anything else you want to see, you want me to go through and learn alongside you, please comment in the sections below, and I'll try and reply. Alright, well, thanks very much. Take care, and I'll see you again soon. Bye bye.